Okay, well,
Or his phone's on silent.
yes.
I should probably
Please be kind. Turn off your phones now. It's a very important presentation. No, so yeah, basically becoming a daemon, only on Linux, primarily because I've only tested this thoroughly on Linux. As I said earlier, it probably works on OS X. Probably doesn't work on Windows unless you have like active Perl and a whole bunch of other things installed. So basically just the get-go for it is just what is a daemon? And it's basically, it's a Latinized word of a Greek word, which I can't pronounce, but I found it. Basically during the Greek and Hellenistic religion mythology, they were good and benevolent supernatural beings, somewhere in between gods and mortals, and they were to help men. And it wasn't until Plato came around with one of his students that they created an evil version of that, basically the demons which we know now. Which I find is pretty much funny because both of those images are actually wrong because they are more of either the little devil or seductive, which isn't actually the original version of a daemon. But as we know it, it's basically a background program. So basically, what is a daemon as far as a software program? It is something that detaches itself from the terminal and the user, and so it runs in the background with no interference from us. It changes its working directory, and I'll get into the reasons as to why. It changes the file creation mask to a state that you know rather than just not knowing it and not being able to create files that don't write. It normalizes certain things, specifically the environmental variables and the path, so it can still find the things that it needs without having access to things that could be used against it. It creates a process ID file, which is basically like locking, like for a file lock. It's this way so the server doesn't run twice if it's not, which it shouldn't be. And also, it sets up logging. Since it's detached from the user and the terminal, if something goes wrong, you can't know about it because it doesn't write to anywhere. So you need to use logging. I'm using the Perl module syslog, and it's a nice interface to the syslog daemon. Also, it closes, of course, standard in, standard out, and standard errors, and that's why we need the logging. One good thing to know is on CPAN there's proc daemon, which basically takes care of all of this. So I guess halfway is the question is, why do we have this presentation? I guess it's so you know what actually is happening to create the daemon. Also, real quick, I'm just ripping off this book, the Network Programming with Perl by Lincoln D. Stein. If you're going to try any of this, I would recommend picking this up because that's pretty much where I learned it, and some good examples in there. So basically what we're covering today is Tainted Mode. It's a good idea to run your server in Tainted Mode, and it's a headache, but we'll get into that shortly. Also, primarily we're just covering how to initialize the server, and the primary portion of that is becoming a daemon. But again, it also talks about logging and process permissions for the server itself. What we won't be covering is forking. Now, I'm kind of lying with that one because I'll give you one slide on forking, which gives you about 90% of what you need to know for it, but it's the other 10% that'll kill you if you're not careful. Not going to be covering sockets, which is basically a primary way that children will be communicating with the parents. Won't be covering children because that's a whole other ball of fish. And process signals. You'll see a couple of them in here, but they really become a part of the child of handling interrupts and dies and all that kind of stuff. So here we go. First thing, Tainted Mode. Tainted Mode is basically started with the capital T flag behind the Perl. That sets it into a hardcore die mode. You can use lowercase t or capital TU, and that just turns it into warning mode. So basically, if you violate it, instead of just crashing on you, it'll just let you know nicely with a warning flag. So basically what Tainted Mode is anything that comes from the outside is going to be, any variables that get populated from the outside is going to be labeled as tainted. And any variable that it comes into contact with also becomes known as tainted. And anything that is tainted cannot access the outside world. And this is security, so you can't just take something in and automatically execute it. So like this is a great example here where basically I'm just reading in the file name from the from standard in. It could be anything, could be an actual file name, could be a command. And the point here is that basically I'm handing off file name to a module and getting an object. Now the object is tainted. And that's the thing to remember. Well, I guess to put it specifically, the data structure that is the object is tainted. You can have class variables inside that object and they will not be tainted, but the core data structure will still be tainted. So you always want to clean up those things. Okay, so here's just a quick example. If you were to write this in here, so basically you take whatever it is and you try to open up the file name for write, you basically get that error message. Perl will tell you that you're running in taint mode and it's an insecure dependency. Now the interesting thing is that if we were to do this for read, it wouldn't complain at all, because reading in, you're not affecting the outside world. So it's only when you're trying to touch the outside world does it actually give you these errors.
So it's because you had write permissions on that file?
Yeah, it's basically, because I was trying to write to the file. Okay. And, God only knows what actually, I have no way of knowing what the file name variable is. That's what it's complaining about. Okay, so again, a tainted variable is anything that comes from outside of the program. It's anything in the environmental variables, anything taken in from the command line, anything from a socket, from backticks. Anything that didn't originate from your code will be considered tainted. And without that, Perl will not let you do anything that touches the outside world, which is basically the single value forms of the system and exec commands. You can't eval on those. You can't write to a file, as we just saw, or piping, the glob, and link, unmask, and kill. So anything, basically, if you are going to touch something outside of your little code, Perl is going to stop you. And believe it or not, it sounds simple, like, oh yeah, I'll just check everything that comes in. It is a pain. Somehow something will slip by and it will come back and bite you in the ass. Almost, pardon me, almost so bad that you want to turn it off. But, I would encourage you, especially with writing servers, it's a good idea to just keep that in there, because if it is complaining, that means somehow you're letting something slip by somewhere. So once you're in the program, I don't even know how to describe it, but that's the variable to check whether you're in, what mode you're in. If that is 1, then you're in taint mode. If it's 0, then you're not in taint mode. -1, you're in that warning only taint mode. So it's a good way of saying, if you're writing code that needs to behave differently because of, especially like in object creation, if you're in taint mode, you need to know to, you can't just accept whatever was given to your object. Okay, so to untaint a variable, use regular expressions. So it's basically right there. We get the file name in, and then we pass it through the regular expression, and then we set file name to what is matched in the regular expression with the parentheses. Now, of course, that's one of the dumber ways to do it, because it'll verify anything. So I mean that's about as useless as not even having taint mode on. But it just is an example, so to turn off taint mode. So if you're looking for a number, it's a number, then of course you just do /d+ and only take that. And if it's not that, you should probably throw an error or die yourself. Okay, so this is pretty much what we're going to be talking about, is this small chunk of code, which actually gets much bigger and much more complicated, but this is what you need to do to initialize a server. The first step is just to check the process ID file. Basically here, the first thing you want to do, is it there? If it's not there, that means, well, server either isn't running or hasn't been run, or if it's running, then it's not running right. But if it's not there, we don't do anything, we just come back out. If it is there, then what we do is we read in the process ID file name. Of course, that's a variable that I have already made sure that it's not tainted somewhere else in the code. And I read in the process ID from the file handle. And then I basically take a look and say, is this all digits? If it's not, I die with invalid process ID file. If it is a valid, if it is just a digit, we send the kill 0 to it. Now this is a interesting command. It just kills whatever process you give to it. But with the 0 flag, all you're doing is saying, see if it exists out there and whether it's ready to receive a kill or a signal. This only works if you're either the user that is of that process or if you're the super user, root. So in other words, if your user Erik, and I'm trying to see if Doug's program is still up and running, this is not going to return anything for me because I don't have control over that process. But as root, which all your servers you should be initially running as root, will come back and say, well, either I found them or I didn't. So if kill 0 to the process ID, using the $1 there, returns something, I die saying, okay, the server is still running. There is the recorded process ID, the lock, is still active. If it's not, they just send out a nice little warn saying, okay, I'm going to remove the process ID file, and then you basically just unlink it. And if you can't unlink it, then, whoops, sorry. If you can't unlink it, you just die saying, well, something else is wrong. Please take a look at this, and you'll have to go either remove it manually or fix it.
This is where you just say sysadmin fix it.
Yeah, pretty much. Of course, that usually you're the sysadmin too, so.
And they'll say open a ticket.
Yeah, true.
Like, dang it.
So that's the whole thing about checking the process ID file. It's the locking mechanism of the server, or like a lock file. Then the next thing we do is we open up a file handle to the process ID file name. The reason we do it here before we become a daemon instead of afterwards, inside the PID file function, is that if we can't open or write to it, we want to know before we start the daemon. There's nothing like starting a daemon and then having to go check the logs just to see whether you created the dumb file. So that's why you open that up first. Is if you can't write to it, it'll tell you right away, and you know that there something else is amiss. The only reason why you do that there. So we have the file handler for that, and we're going to put that on hold for a little bit because now we're going to do the actual meat and potatoes of the server is becoming the daemon. So this is where the first thing we do is we fork the process. And this is the little crash course on forking that I promised. Basically, forking, all it does is it takes your program and creates a secondary. And everything is identical to it, with the one exception of what fork returns. And we'll get into that in a second. The thing to remember is that all file handles, pipes, and sockets are shared in between the two. So both, like right now, to standard error, standard out, and standard in, they're both owned by the child and the parent, and they can both utilize them. They're open to both of them. What fork returns is either 0, a process ID number, or undefined. If it's undef, that means fork failed and you have other problems, like you were running it on Windows. But basically,
always a problem.
Yes. Basically, if it returns 0, you're in the child program. If it returns a process ID number, you're in the parent program. Normally, the parents will use that number to make sure that it can reap the child so you don't have zombies running around. But since this is a server, it's actually the parent that we really don't care about. So basically, we've created now the two processes, and the very next thing we do is we exit 0 if we have a child. In other words, if we're the parent process, we kick the bucket. We don't care about you. So all we now have at this state is the child process still running, and it's going to go on to this next POSIX set SID. And it does most of the heavy lifting, and this is kind of where it gets a little bit beyond me because it gets more specific as far as how Unix handles things. But basically, the thing to realize that in Unix or with processes, it's more of a group of programs or processes running. The easiest place where you've probably all seen this is that if you're in a shell, and let's say you're doing a VI or something, and you hit Control-Z to send that into the background, that's pretty much it. You have your shell and your VI process, and they're both in that group, but right now the session leader is your terminal or your shell, and your VI isn't. Now you can bring that back, up to, you can bring the VI back up, and now the VI is it's called the session leader, and the session leader is the one that has command of all that. Now, one thing to remember when calling the set SID, it cannot be called by the session leader. So if the parent, let's say if we didn't have, right above there, if we didn't have that exit 0 of child, the very next thing it would blow up on because the parent can't call this. It has to be one of the other non-leading processes. So basically, once it's called, it creates a new session and a new process group, and it makes that process the leader of it. And it disassociates it from the terminal. Now, there is a variation on the whole daemon thing because for reasons I don't understand, and I'm just mentioning it because it's mentioned. At this point, this process still has access to dev TTY, and there is an ability for it to regain access to that controlling terminal that the parent had. But for some reason, if you were to fork it again, it wouldn't. But from what I understand, that's just one of those esoteric issues that most people, you're just never going to run into a security hole where someone has infiltrated your server and turned the terminal back on. So most servers, most production servers just fork once. But so anyway, the important thing to remember is that the sets SID, it basically really pulls the child and turns it into its own parent, basically. The child's grown up. The next thing we do is we close standard in, standard out, and standard error by just pointing them at dev null or receiving from dev null. The nice way of doing it this way, where you're putting standard error back out to standard out, is that if, let's say, you're in the beginning stages and things just aren't working right, you comment out the open standard out to dev null, and then that way any kind of weird errors, any kind of weird messages still get to the terminal. It's a very crude debugging tool, but when you're at your wit's end, anything helps. So that's a nice little thing to remember. Go ahead.
Am I right in saying that basically ties standard error to standard out, which is tied to dev null?
Correct.
Okay.
So yeah, it would be the same as having dev null there again, but yeah, but this way I only need to comment one line out if for some reason I need to see what in the world's going on. Okay. Then the next thing we need to do is change the dir to root, and this is basically that if for some reason the server starts in a directory that may become unmounted, and that server is trying to interact with the file system, all of a sudden it's in a place that doesn't exist anymore. And I'm not sure exactly what the errors for that would be, but it just doesn't sound like it would be a good thing. And then, of course, we want to set the umask to a known state. Now, basically, all this is that if your server creates files without specifying the creation mask, this is automatically what's going to be. Now, this is the inverse. It tells you what each group can't do. So, in this sense, basically, with the 002s, the first 0, of course, means that it's an octet that we're reading. The 022 just means that the file permissions are going to be 755. So the owner can read, write, and execute, and everybody else can just execute and read. And so basically, yeah, if you just pass it a 0, which actually is the example in the book, the file permissions will be 777. Of 007, then, of course, only the owner, the owner, or the server owner can actually read and write and whatever with the files. So I just prefer the 755 because I figure if I'm creating it or my server's creating it, I don't want anybody else to really be able to mess with it while I'm away. So next thing is we sanitize the environmental variables. I'm always, I like the heavy-handed approach where you just nuke everything. So of course you need to be very careful with this. If your server requires something to be in the environmental variable, you either need to not nuke it or do so, or recreate it afterwards. As you see there, then the very next step is I reset a path so it can find normal executables. Now, depending on how I lost the word. Depending on how sensitive the data is your server is going to be working with, or what kind of system, you may even want to prune that down further. You may just say, okay, I've loaded everything. I don't need anything in a path because I'm not going to load anything more. If you need more Perl modules at a later state, you'd probably want to put your Perl directory into there. But it's much easier just to load them all ahead of time. So it's one interesting factoid is that, let's say, originally the author, he uses carp and croak, which are part of, anybody? CGI, that's a module. Oh yeah, it's just carp. I'm sorry. Sorry. Thank you. Right, it's just the carp. But the funny thing is that carp requires another module called carp heavy, which it doesn't load right away. It only loads it the first time it gets executed. So if you don't have use carp heavy, and then you basically obliterate from your path where the Perl libraries are, the first time you croak or whatever, it says, well, I can't find this. That's because you've removed it from the path. And it's just a security feature, and most of this is for security purposes, is why you're jumping through these hoops. And the last thing is, of course, all the children need to be taken care of. Otherwise, you'll just have zombie children running around. As I said, we're not really going to be talking about signals, so I'm just showing you that this is where you'll be dealing with reaping of the children. But that's something that we'll actually get into when I talk about children at a later date. So back to initializing the server, we've become a daemon. We're our own process now, and we just need to write the process the process ID file. We have the file handle, so we just pass that in, and of course the $$ is the current process ID. We write that to the file handle, and then we close the file. And then we save it for later because we do need the primary server's process ID number, so we can do something with privileges a little bit later.
Shift is the first argument, right?
Yeah. I'm basically shifting. Yeah, I'm shifting the file handle that I pass to it.
Okay.
Yeah. So, and I've adapted this because when you want to see this, I actually have a working version of all this code. But I've turned the entire daemon process into an object. So when you see this function, the first thing is actually shift self and then shift the file handle.
Okay.
Yeah. So now basically we have our server, we have everything taken care of, we've locked it. Now we need to set up the logging, because this is the only way that you're going to know anything about what's going on in the program itself, in the server or in the children. Without it, you are flying blind. And I recommend the syslog, because that uses the syslog daemon on Unix, and basically that's controlled through the etc syslog.conf, where you can set up just any kind of rules and whatever you want on it. I'm not going to really go on to how to configure it. I'm just assuming that you have a working version of syslogd running, and you can go into that later. So this is basically what you're going to find. This is actually the way that the daemon is set up. It's actually writing into varlog syslog, and this is what you'll see. It's a line that says the date. This is the server ID. It's basically, you can have this thing, so you can have a remote server and every other server is just sending to it, or you're just writing locally. So the next thing is just what your server name is, so you know where the message is coming from. And this is just the set name is just a name that you've given it. You can call it whatever you want. Good idea, just call it the program name. So if you have a ton of these, you'll know what you're talking about. The next in the brackets is the process ID number. And you can actually omit that if you want to, but of course if you're dealing with a parent and children, you need to know that so you know which one you're actually in when it's writing a message. And the last part is just the message itself. So, very simple. And the nice thing with syslogd is you don't need to worry about the fact that you have two servers trying to write to the same source at the same time, and you don't have to worry about conflicts, because the syslog daemon takes care of all of that for you. And that's the whole reason for using something like that versus trying to roll your own, where you're going to have to start worrying about who can talk to who, and any type of buffer cutting off the buffers. And so just real lazy way. So three pieces of information that syslog needs. It needs a facility, priority, and the options. So facility just tells it pretty much which one of the syslogs to write to. For this end, we're using Daemon, but obviously you can see there are several others as far as you can choose from. I guess if you're going to write a mail server, you'd use mail, and so forth. Also, local 0 through local 7, those are just arbitrary ones you can use. Again, if you were just trying to, in the syslog, trying to separate out your messages from other logs and create your own. And again, even if you do create your own rules in the syslog, the syslog daemon does take care of the log rotating and compressing, so you don't have to worry about all of a sudden just filling up your disk space with a whole bunch of errors, because it will take care of that. The priority, of course, this is in each individual message, and so that way, again, syslog knows how to handle it from least important to most important. It goes from debug all the way to emergency. I put the little double pipe in there just to that separates the just informational priorities from the something's probably wrong priorities. So, if you just want to say, hey, I'm accepting connections, you want to either use notice or info. If you want to say, hey, this variable is uninitialized, you probably want to use warning or error. If all of a sudden, hey, I'm trying to write to this file and the file won't open, you'll probably want to use critical or alert or emergency, depending on how much you really need access to that file. And the last thing, the options is obviously the process ID. That using that option puts in the process ID in the messages. Then the other three are basically cons. If you do still have the console connected to your server, let's say if you've commented out the rerouting standard out to dev null, that will print everything that goes to syslog to the console. So it's a nice little thing of just add that in. So now you don't have to have your window open that shows you the syslog at the same time as you're trying to debug it.
Will that work if the standard out is also commented out, or does that need to be there?
No, it needs to be commented out because otherwise it just writes it to dev null.
Okay.
Yeah, you'll never see it. So yeah, that only makes sense if you still have standard control of standard out.
Gotcha.
So end delay basically means don't wait until basically the syslog daemon doesn't really activate itself until the first time you call it. Using end delay means that the minute that you create your server, it'll start that connection. Really, I guess that'd be more of a performance issue, but I've never. I mean, to me, it always seems like seamless. No wait also means that in its default state, it sends out the message and waits to hear back from syslog before it goes on. The no wait means it just sends it out. It's the communications via UDP, so it doesn't really need a hear back. But the no wait just means it fires it off and immediately returns back to your program. So, yeah. Mm-hmm. And again, if even if you were running it normally and you had it all detached, it really wouldn't matter if it was waiting or not. You wouldn't be able to do anything about it unless it was just really slow and you thought that might be one of the way. Probably, especially if you were doing it over a network. That's definitely when you want to turn that option off. So basically, syslog gives you three methods automatically. The fourth one you need to tell it to export when you're calling it. It does not export this one, the bottom one, by default. Basically. Very natural progression. The first one is open logis. Basically, you're telling, okay, I want to use syslogd, and the first argument is the name, and that's where we saw there that is basically just the name that gets put in there, so you know what program you're in. The second argument is the options. It's space delimited. So in this case, we only want the process ID numbers, but let's say if you wanted the no wait, it would be PID space no wait. And the third one is the facility we're using. Of course, we're using Daemon, but you could use any of the facilities on the previous page, and of course that's all on the docs too. So then of course to write to the log server is just syslog, then the level the priority, which in this case is just warn, and then the message. Now the message it does adhere to the printf scheme, so you could do something like that. Couldn't open %s for %s with %m, and then give it the arguments afterwards. Now in this case, when you use it this way, %m is used in place of the $! So like if you're opening up a file, you usually use $! To tell you why. Well, that's the m displays that information. And the last one that it automatically exports is closelog, which you really don't need to use because once your program is done and goes out of scope, it cleans that up itself. So it's there in case you want to close it for some other reason. But the last one, you only need to export if you're running a local server and you're going to be communicating to the syslog daemon locally. It only accepts two arguments, either Unix or inet, and the default is inet. And inet basically says that I'm communicating to something outside of. I'm sorry. Yeah. Thank you. And but since basically we're running locally, we want to send to the local one. We just say Unix. Okay, so this is basically the. The initlog code. First we call the setlog sock with Unix, saying it's going to be local. Base name, that comes from a module called file : base name, and all it does is it takes from $0, which is the program name. It just takes the last portion of it, the file name basically, and it returns it so that I can just open the log with whatever the program name is, specifying process ID only, and then I'm telling it the facility is a daemon. And of course, since we're logging logging and we've already detached from, the standard error and standard out, we need to redirect the warning and die. And so again, you just set the sig die and sig warn. And what I've done here is basically I've just created two methods. One that specifies, this is a die, this is a warn, and as you can see, I also have debug and notice. And this is so that if I ever choose to use something else other than syslog, I don't need to go rewriting all my clients and children. I just need to rewrite. No, just clients. Excuse me. I just need to rewrite the server itself, and all it does is call log message with the priority level and the error that it received. The only difference is in log die, and basically we invoke die there, and Perl is smart enough to know that, okay, I'm invoking die within a die. It's not going to, continually die. Exactly. Pardon me. So basically, when we die, we want to see why it's dying. And we're going to tell it, hey, this is a critical issue. This was a die. But the $$S, it tells it when it's dying. If that is set to 1, that means it died with inside an eval. And the idea is that if it's inside an eval, you are already taking care of, either you don't care that it's dying, or you're throwing an exception or making other things. You don't need to log it because you are okay with it dying. So that's the only important part there, is the little $S. Yeah. If it's either undefined or 0, then you're not in an eval.
Which means your code is the one that blew up.
Yes.
Okay.
Or, well, either way, your code blew up. It's just in an eval, you decided it can blow up, and I'm okay with it blowing up. Because I either want to handle it this way, or I just don't care if it didn't happen at all. So basically, this is my log message. It just takes in, it takes the first argument. It takes what kind is it, a debug, warn, whatever, and then it pulls in all of the error message, or just supplements something, something's wrong, so that that, okay, something was called, but it didn't generate an error message. And then we use caller function, which basically gives you a little stack trace of where it's happening. And very important, you call it with a 1, because if you just call caller, then basically you'll get to say, oh, I died in log die. And you don't want that. You want one step further up. So, whoops. So that's pretty important. And then on this line here, we follow the same kind of convention that die does. If you die with a carriage return in your error message, it does not print out the line number. Same thing here. If your error message has a carriage /n at the end of it, we don't add on the file name and the line number. We just put in exactly what the message was. If it doesn't have that, then we add that on because it's probably an unexpected error. So basically it's a way so that you can send log messages to the logs where where it's at, and it's actually usually a positive message. Like in the server, it says, oh, I'm accepting connections from this one. Or when a client connects to it, it says, oh, I've received a connection request from here. So those things you don't need to know what file and what line it's in, because those are obvious. So the last thing really to talk about really is just the privileges of the program that it's running. And basically, when it comes to privileges, every program has a real user ID, group ID, and an effective user ID and group ID. The real is what launched the program. The effective, it's what's running the program. Now, basically, a regular user could change the effective user and group IDs, but this only happens under very specific circumstances and under a very specific compilation of Perl being compiled. And if you're on a system and the sysadmin won't give you root access, but will allow you to do all this so you can change your own effective user, then you have a dumb person as a sysadmin because they've just given you root access. Right. But so basically, we're just going to talk about is we're running it as root. So the real group and user will be root, and the effective is pretty much whatever we tell it to. In the server,
if you're using sudo as the real user you and the effective user is root.
Oh, I don't know about that. Unless wait, or what do you?
I don't know.
Can you? Okay.
I'm asking.
Well, but I mean, if you're using sudo, the real user then is whatever you've sudo to, which will be root, wouldn't it?
sudo and switch user, but if you just sudo and run the command.
Well, but then in that sense, wouldn't it be root under your environment?
Yeah, I don't know how sudo works internally.
I-
I'm just curious.
I didn't. I'm gonna have to check that out because what I think happens is that the sudo that lets you run as that user. Now, whether you switch to that user or not means that you're running in their environment versus your environment. But we've already obliterated the environment, so we really don't care. So I don't know. I'm going to check into that because that's a good question. So yeah, again, you're running it as, and the whole purpose for this is that okay, you started the parent process, which got killed off, and so you had a child which grew up to become its own parent process, and now it's root as well. You don't want that. Server running along as root. Primarily, I mean, obviously, yeah, someone can compromise your code and use it to do bad things on your server. What's even worse is you do something stupid on your own and then blow away your own server. And if you'll give me a real quick story of that, is at 2 jobs ago, I wrote a little program that basically monitored network traffic, and upon certain events, it would then do call snort, which is an analysis program, do the logs, sift through the logs, and then report back what it found. Well, the first time it ran fantastic. The second time it ran, well, it had to pull from its config file where all the files supposed to be, and then we need to remove the old log files. So I, put that into a hash, misspelled the directory name, and then added /star, and then I basically ran rm-fr/star on my server. I ran that twice before figuring out what was going on. If I would have heeded this, it would have started running that command, and then says, well, I don't have permissions to delete anything outside of my directory. So it is not only for outside intruders, but it is also for you, because if you do something stupid, you don't want to be blowing away the server. The first time I was able to blame it on a hack. The second time I had to take the rap. So basically, so we have the server privileges, and when we created the little server object, we passed in, okay, we want it to run as this user in this group. So those are both get PW name and get group name or GUR name. Those are both standard Perl calls. They basically take in the user and they try to determine the username and the group user ID and the group ID. And then what we do is we set the effective group to the group ID twice, and the reason for this is that there are, I wrote this, they're called supplemental groups. Some systems have supplemental groups, and the only way to wipe them out is to basically say this is the group, and this the primary group, and this is the supplemental group. Otherwise, you'll have a primary group, and then a supplemental group will still be the original group, which would be root. Then you set the the real group ID also to the new one. Once you set the real group ID and the real user ID, you can never unset them. That's basically, once you've relinquished root command, you can't say, oh, I want to be root again. This is why, for the server at least, we do not set the real user ID. And this is because, we run. When it's time for the server to die, we have this end statement. And the effective user needs to become root again so that we can unlink the process ID file. Otherwise, if we try to unlink it, it's basically just going to die and say you don't have permissions to delete a file created by root, especially since I gave it the permissions of 644. And, well, that was it. That's your initial server. Is everything from the forking to the permissions to everything else. And, yeah, if you want, I do have... I do have, if you're interested, I do have it up and running, and I don't know if you guys are interested in seeing it. It's basically, this is the server, so this is putting together my server object.
Can you go through the code?
Well, I mean, sure. I mean, yeah,
You said you changed,
Oh,
made it up.
I'd rather not. I mean, the only thing different that you didn't see is you didn't see self all over the place, and you didn't see the taint mode, which I screwed up. So when I go through the child, I'll be more happy to show the internals, and I'll show you another problem with why I don't want to show you the internals of my code yet, because it works for this demonstration just fine. But basically, okay, so I basically give it the group and the user for this computer. They're both conference. I tell it the reason why I make this all so specific is because I'm running it as the conference user. I'm not running this as root. So it can be done too. I'm running it and then changing the privileges back to myself. And okay, so here's just the socket so they can connect. But here, that's the whole thing. I've just created the server right there. And what you'll see in the log file, which is right there, which I'll clear up in a second, is basically it'll say server accepting connections, and it'll sit there waiting for the socket. So I'll just grab this over here. That's not going to work. So basically, I'm just running the server. So that's it, accepting servers. And down here, you see the parent process, and it's running in taint mode. And of course, I was running it before, so the process ID file existed, so I got all the junk. So then I just run the client. Well, I run the client. I don't run the server again. There we go. There we go. And then these are my debug statements. And here you can see the difference. I called this prepare the child. I called that without a carriage return at the end, so I got the whole message where it was called from. And whereas other lines like closing individual connection, that was just a regular one with a carriage return, so I didn't get the extra junk. Oh, and also very important, syslog does not handle carriage returns in the message very well, or tabs. So that's where this is a data dump, basically right here. So that's carriage return, carriage return. So, and that's it. We're up and running with the Elise server. So and then you can just interact with the bot all day long, and we can connect. We can create a second one. So. So and you can see the clients adding up. The only problem, and this is why I don't want you guys to see my code just yet, when I leave, well, as you can see, a lot went away. This server's still up and running, and just also happy. But when I exit, well, my main server dies. So I need to fix that before I give up the child version of this. But so yeah, that's basically it. That's really all you need to initiate the server. Okay.
Cool.
All right. Okay, so it wasn't that long.
That makes up for me.
You were talking fast.
Okay. I didn't stop for my water breaks. Any other questions or?
Yeah, that's good. It's more about Earl and David.
Yeah. But yeah, and the taint mode is a problem, which I didn't even think about that at first. I turned it on, and then I called my object, and all of a sudden I couldn't open the process ID file. I couldn't do anything. It's because the way that I have a generic new function that I use for everything, and it basically just takes whatever you pass in, and that becomes the core data object. And so with the taint mode, it needs to be passed to like an initialization function, which then, it takes each argument and puts that into an internal data structure, untainting each one as it goes along. So yeah, taint mode is a pain in the butt.
It's like it helps you make sure you have your safe code by the time you get it running.
Mm-hmm. Most definitely. But cool.
Did you want to ask about future?
Oh yeah, I mean, I guess. Yeah, as I said, what I'm not covering is basically a whole nother presentation and just talking about children, and even like the I/O sockets, and even the finer parts of forking. So if there's interest in that, I can create those as well, but it'll be a little bit before I can put them together. So,
Yeah.
okay.